The CR450 represents the next evolution in high-speed rail, pushing conventional train technology close to its physical limits. Designed for speeds up to 400 kilometers per hour, it redefines efficiency, aerodynamics, and stability in modern transportation. At extreme speeds like 400 kilometers per hour, air resistance becomes the biggest challenge. The CR450 solves this with a highly optimized aerodynamic design, reducing drag and improving energy efficiency. China's high-speed rail network is the largest in the world, and the CR450 is its most ambitious project yet, aiming to transform long-distance travel into a faster and more practical experience. The jump from 350 kilometers per hour to 400 kilometers per hour may seem small, but in engineering terms, it requires massive improvements in power, materials, and safety systems. The nose of the CR450 is carefully designed to reduce pressure waves when entering tunnels, preventing loud noises and improving passenger comfort. High-speed rail, like the CR450, can compete with airplanes on short and medium routes by offering faster overall travel times from city center to city center. Advanced sensors in the CR450 constantly monitor performance, adjusting systems in real time to ensure stability and safety at extreme speeds. Energy efficiency is critical at 400 kilometers per hour, and the CR450 uses lightweight materials and optimized systems to reduce power consumption. The CR450 is not just about speed, it's about making ultra-fast travel reliable, scalable, and practical for millions of passengers. Compared to maglev trains, the CR450 uses traditional rails, making it easier to integrate into existing infrastructure. At 400 kilometers per hour, even tiny imperfections in the track can have serious effects, which is why high-speed rail requires extremely precise construction and maintenance. The CR450 represents decades of engineering progress, combining aerodynamics, advanced materials, and digital control systems. Faster trains like the CR450 could reduce the need for short-haul flights, helping lower emissions and improve sustainability. Passenger comfort remains a priority, with systems designed to reduce noise, vibration, and pressure changes during travel. The CR450 is part of a global race to build faster and more efficient transportation systems. High-speed trains are changing how people live and work by making long-distance commuting more realistic. The development of the CR450 shows how quickly technology can evolve when supported by large-scale investment. Safety at extreme speeds requires multiple backup systems and constant monitoring to prevent any failures. The CR450 could dramatically reduce travel times between major cities, boosting economic activity. Unlike airplanes, high-speed trains offer a smoother boarding process and fewer delays. The future of transportation may combine high-speed rail with other technologies, but the CR450 is a major step forward. At its core, the CR450 is about redefining distance, making the world feel smaller and more connected. The CR450 pushes conventional rail technology to its absolute limits, proving that traditional systems can still evolve. Reaching 400 kilometers per hour requires extreme precision in both engineering and infrastructure, leaving no room for error. The design of the CR450 reduces turbulence, allowing smoother airflow across the entire train body. High-speed rail is becoming a serious alternative to air travel, especially for distances under 1,000 kilometers. Every component in the CR450 is optimized to handle intense forces generated at extreme speeds. The train's structure must remain stable despite constant vibrations and external environmental factors. Advanced braking systems allow the CR450 to safely decelerate from very high speeds when needed. The future of travel depends on efficiency, and the CR450 is built with that priority in mind. Reducing travel time changes how cities connect, making distant locations more accessible. The CR450 is designed to operate reliably under continuous high-speed conditions. Precision engineering ensures that passengers experience minimal movement inside the train. China's investment in rail technology has accelerated innovation across the entire industry. The CR450 demonstrates how infrastructure and technology must evolve together. Even small aerodynamic improvements can significantly impact performance at high speeds. The train systems are constantly monitored to detect and respond to any irregularities. High-speed rail networks require long-term planning and massive resources. The CR450 reflects a shift toward faster and more efficient ground transportation. Modern trains rely heavily on data and automation to maintain safety standards. The challenge is not just speed, but maintaining control at that speed. The CR450 is engineered to deliver consistent performance over long distances. Noise reduction is essential to ensure passenger comfort at extreme velocities. This train represents a balance between power, efficiency, and stability. The faster the train moves, the more critical aerodynamics become. High-speed rail is shaping the future of global transportation systems. The CR450 could redefine what people consider a long-distance journey. Innovation in rail technology continues to push boundaries once thought impossible. The CR450 is not just faster, it's smarter and more efficient. Infrastructure quality directly impacts the performance of high-speed trains. At extreme speeds, even minor adjustments can have major effects. The CR450 shows how far engineering has advanced in recent years. Transportation is evolving, and high-speed rail is leading that change. The goal is to move more people faster, without compromising safety. Every detail in the CR450 is designed with precision and purpose. High-speed trains reduce travel friction between major economic regions. The CR450 is built to operate at the edge of current technology. Future systems will build on the foundation created by trains like this. The CR450 highlights the importance of innovation in transportation. Efficiency at scale is what makes high-speed rail so powerful. The train's performance depends on perfect coordination between systems. At 400 kilometers per hour, stability becomes one of the most critical factors. The CR450 represents the next milestone in railway engineering. Speed alone is not enough. Control and reliability are equally important. The evolution of trains reflects broader technological progress. High-speed rail continues to transform how people travel. The CR450 is designed for both performance and long-term sustainability. Advancements in materials play a key role in achieving higher speeds. The train must maintain balance even under extreme operating conditions. The CR450 proves that rail transport still has room to grow. The CR450 is engineered to maintain peak performance over long operational cycles without compromising safety. At extreme speeds, temperature control becomes critical to protect both systems and passengers. The train's lightweight structure helps reduce energy consumption while maintaining structural strength. High-speed rail, like the CR450, depends on perfectly synchronized systems working in real time. The margin for error at 400 kilometers per hour is extremely small, requiring flawless engineering. Each journey on the CR450 is supported by advanced predictive maintenance systems. Digital monitoring allows engineers to detect issues before they become problems. The CR450 is designed to operate efficiently across different weather conditions. Strong crosswinds can affect stability, which is why aerodynamic balance is essential. The train's design minimizes vibrations to create a smoother passenger experience. Precision-built tracks are just as important as the train itself. The CR450 reflects the integration of engineering and data-driven technology. Every kilometer traveled at high speed requires constant system optimization. High-speed rail reduces dependency on congested road and air traffic systems. The CR450 is built to meet the growing demand for fast and reliable travel. Even the smallest design flaw can impact performance at these speeds. Engineers must account for thermal expansion caused by high-speed movement. The CR450 operates within extremely strict safety parameters. Its systems are designed to respond instantly to changing conditions. Passenger cabins are pressurized to maintain comfort during rapid travel. The train's efficiency depends on minimizing resistance at every level. High-speed rail continues to evolve with advancements in technology. The CR450 represents a new benchmark for conventional rail systems. Maintaining stability at high speeds requires continuous adjustments. The train's control systems are among the most advanced ever developed. Infrastructure and technology must evolve together for maximum efficiency. The CR450 is part of a long-term vision for future mobility. Faster travel can significantly impact economic productivity. The design process involves years of testing and refinement. Every component is built to withstand extreme operational stress. The CR450 is optimized for both speed and reliability. High-speed trains reduce travel uncertainty and delays. The system must remain stable even under unexpected conditions. Continuous innovation drives improvements in rail technology. The CR450 showcases the limits of current engineering capabilities. Efficiency improvements help reduce operational costs over time.